Hello, we are Enei, Eric, and Eduardo, and we are the 3E team. In this video, we will show the progress of our EcoHead shower project, developed in Seminar 2. Before we begin, we want to share a context that highlights the relevance of the opportunity we are addressing. Mexico is facing a serious water crisis, aggravated by factors such as climate change, overexploitation of aquifers, and insufficient infrastructure for water management. In 2024, 75% of the national territory will be affected by some level of drought, significantly impacting both urban and rural areas. In Mexican households with an average of 4 inhabitants, it is estimated that around 150 liters of water are wasted per day due to bad habits, such as leaving the water running while waiting in the shower or during activities such as washing dishes and clothes. According to the EPA, approximately 20% of the water used in a shower is wasted while the user waits for it to reach the proper temperature. Since an average shower consumes about 65 liters of water, this 20 during Seminar 1 and based on the methodology described in the book on design and development by Ulrich and Eppinger, we were able to establish the mission statement of our product: modernization of the shower system for homes, for installation in the exposed pipe of the existing shower system, reduces the time of hot water output by opening the system at the start of the shower, controls the flow, and mixing to obtain the desired temperature before the shower head comes out. This description identifies the basic function of the product, avoiding implying a specific product concept, and which we see as a statement of the vision of what the product should be. In addition to this, a series of interviews were conducted with our potential clients, which helped to establish a list of needs that served as the basis for this Seminar 2, in which we will address the product specifications. During this presentation, we will show you the path to generating the specifications of our product, the benchmarking, the search for patents that allowed us to establish the marginal and ideal values of our product, and we will close with the clarification of the problem as the initial part of the generation of concepts that will allow us to understand more about what we want our product to do.
A part of the final list is presented, highlighting that the list has 43 needs that emerged from the interviews conducted previously. This list was corrected based on the teacher's comments and was assigned a level of importance after discussing it as a team. The process we carried out to generate metrics applicable to the aforementioned needs is presented. This was a process where research had to be done to determine what type of unit would be most appropriate for the metric. It is important to mention that we generated 53 metrics. Creating this matrix is a key step that helped us ensure that each need is associated with a specific metric, allowing for effective monitoring. In the matrix, the relationship between need and metric is represented by a marked X, which makes it easier to visualize how both elements are connected. It is worth noting that in some cases, a metric can be associated with more than one need, reflecting the interdependence between the aspects evaluated. This approach not only optimizes measurement but also provides greater flexibility and a broader understanding of the impact each metric has on meeting the established needs. The next step we took was the creation of the final list of metrics where the need number was placed since there are metrics that apply to two needs. Likewise, it was very important to define the type of unit. For example, binary, liters, seconds, etc., so that the metrics were coherent. At this stage, we conducted research into existing products on the market that could be direct competition to our project. Therefore, we initially tried to avoid biases with in-depth research considering different features, functionalities, prices, etc. After this research, we selected the products that had the greatest amount of information to be able to evaluate their specifications versus our metrics, thus concluding with a selection of 6 products to perform benchmarking. The most important characteristics of the products on the market helped us to identify points of improvement applicable to our project. For example, there are products such as faucet, which has a useful life of only 1 year and requires constant maintenance, in addition to being made of low quality materials. On the other hand, Kenda stood out for areas in materials and durability, but it was also the heaviest. We understand that each product is aimed at a different public, but that they share the need to heat water for their shower. In this step, we filled up the benchmarking table of the metrics with each of the selected products based on the product information. It is important to mention that in some metrics we had to make some comparisons with similar products since the internet pages do not have all the detailed information. This step helped us visualize the different specifications and characteristics of each product manufacturer compared to our generated metrics, which helped us better understand the market and what they offer to users. In this step, we determine the competitive benchmarking in terms of the client's needs, interview process, and we use a scale from 1 stars to 5 stars. So the more points obtained, the greater the satisfaction. In this evaluation, the needs previously established were considered and the objective is to determine how well the 6 selected products meet the needs that we detected in the interview process. What we were able to observe is that some of the products have a low level of satisfaction for some needs, which could be a point in favor of our product. So if we consider them, we could be a differentiator in the market.
In the process of searching for patents, we follow the instructions of the document that Dr. Weaver shared with us. First, we described the invention, then we identified the relevant classifications. We reviewed the definitions of the classifications, then we carried out the search, selection, review, referencing process using the CPC. We also carried out the search in Google Patents and Espasana. In the end, the team was able to obtain conclusions of the process. In total, there were 106 patents, so this was a rich source of technical information on previous solutions and the state of the art of shower systems. Analyzing the patents allowed the team to understand what has been tried before and what gaps can still be exploited. It will also help us ensure that the proposed design or technology does not infringe the intellectual property rights of third parties. During our search, we found interesting innovations, from a bath with UV light so that anyone can use it, also water heating by thermal energy, dispersion systems that save water, recirculation systems to mix water, etc. All these searches they were with the aim of reducing water waste during showering. It is important to mention that the team tried to avoid bias. For this reason, our search was very extensive and broad, in order to find information that could be useful for the next steps in product development. Knowing the limitations and opportunities that existing patents offer us helps us boost creativity, since the team is challenged to develop unique or improved solutions that provide differential value. This is because we were able to detect possible flaws in heating, installation, sizes, ease of use, etc. In the search, we managed to identify a patent with the description of our problem: avoid wasting cold water before hot water comes out. In this patent, we were able to identify good and bad points, and in the end, we want to avoid modifying the hot and cold water installations in homes. Carrying out the development of the process allowed us to identify opportunities to improve existing developments, avoid risks that we detect in the developed patents, protect our innovation, have a visualization of the issues that are being solved, and mainly give us an overview of how we can meet the needs of our clients. In the process of developing the target specifications, we review the list of needs, the list of metrics, the need and matrix, and the competitive benchmarking in order to ensure that all the observations made by the teachers were corrected. This step establishes clear, measurable goals that guide development to our key client needs and project constraints. So this step provided us with a solid foundation to evaluate design alternatives and make informed decisions during development as well, allowed us to align the team's efforts with market expectations and available resources, maximizing the technical and commercial viability of the product. In essence, it is the bridge between the client's needs and the technical execution of the design. Here are the 5 most important metrics and needs. It is important to mention that the team worked to evaluate all metrics and needs because the target specification step defines the focus of product development and ensures that the team's efforts align with key project objectives and customer expectations. Therefore, we consider that the target specifications process helped us prioritize resources and efforts, align the product with the user's needs, avoid requirements overload, establish clear parameters for decision making, facilitate evaluation and validation. This ensures that the product has a clear focus and is designed to maximize value for customers. In total, there were 53 metrics and 43 needs. In the target specifications process, we verify the relationship between metric and unit, with the objective of obtaining the marginal and ideal values. Using the information from benchmarking, searches for other systems, regulations, available videos of existing products, the review of technical sheets and safety sheets, and with the information we have obtained throughout the process, we determine the marginal and ideal values. We also carry out the justification of each value, both marginal and ideal. This helped us make the selection of the values clearer and mainly because it is part of the process for obtaining the values. Finally, we evaluate each metric with a level of importance in order to know which metrics are the ones we want to be the best at. The metrics we want to be among the leaders, those that the average performance is fine and those that would not be so necessary that we could comply. At the end of the process, he gave us a vision of the metrics we must meet if we want to generate differentiation in the market.
We have concluded with the specifications of our product, considering the benchmarking and the patent search. This has allowed us to know what exists in the market and how much our product meets the needs of our users. In this first step of the concept generation, we will try to have a clearer understanding of the problem by breaking it down into sub-problems that allow us to have a clearer vision of the system. Dividing a problem into sub-problems or simpler parts is called decomposition. Today, we present 3 schemes in which our problem can be broken down: functional decomposition, decomposition by user sequence, decomposition by key user needs. To carry out this step, it was essential to delimit our area of analysis and comprehensively understand the main problem related to water waste. The following diagram illustrates the path of hot water from the heater to the shower head, showing how, at the beginning of the process, a section of the pipe contains cold water before reaching the desired temperature. The decomposition analysis area is located after the exposed pipe in the handle area and before the shower head. Following the methodology, this black box is shown, which represents the general function of the product and operates in material flows, energy, and signals. This represents that the system accepts human energy and other energy, cold water and hot water, and a control signal. At the output, transformed energy, water at the desired temperature, and a visual status as feedback. At the end, it is expected that there will be water remaining in the system. Functional decomposition consists of dividing the black box into sub-functions to create a more specific description of the product elements and their function within the system. For our case, functional decomposition showed that the control of the flow of water coming from the hot water pipe is a critical sub-problem, because at the beginning of the activity, the water in this pipe is cold throughout the entire route. This represents an area of opportunity in the generation of future solutions. On the other hand, at the end of the shower activity, the water that remains in the pipe before the shower head represents another critical sub-problem that represents an area of opportunity to explore solutions on the use of this water. From the decomposition by sequence of user actions, we highlight as a critical sub-problem the adjustment that the system must make to achieve the desired temperature and interrupt the flow and deactivate the system by emptying the remaining water from the system. Finally, the breakdown by key user needs showed that the critical need we must focus on is regulating the water flow to achieve the desired temperature. These 5 critical subproblems are the ones we will focus on in the future to carry out the intensive search. However, it is important to mention that we will be open to correcting them if necessary, since it is important for us that the development of the detection of critical subproblems has been done correctly for a clear focus of the project. The benefits of functional decomposition are: visualize the entire product. By breaking it down into smaller functions, you get a clear perspective of all the parts that make it up. More efficient design. It allows you to design and develop each function independently. Prioritize functionalities. You identify the most important functions associated with the client's needs. Logic in the user sequence. Look for the subsystems to interact with each other, following a logical sequence that reflects the user's use of the system. Improve maintainability. By being well structured, the product is easier to update and maintain by identifying key spare parts. As we have seen so far, the selected specifications ensure that the values used are relevant to the development of the project, aligning with the client's needs. The research, which included patent searches and benchmarking, allowed us to analyze multiple solutions to reduce water waste in shower systems, giving us a broad and solid overview to address the problem. Functional decomposition is a valuable technique for any product development project. By understanding the user's needs and breaking down the system into smaller functions, a clearer design is obtained and its analysis is made easier. Although there are still areas for improvement, the team remains committed to continuous learning and the correct application of the methodology to achieve a satisfactory result. At this point in the seminar, with these findings, we intend to move on to Seminar 3 and do a good job in the concept generation and selection phase, always with an open mind in the search for new solutions. We greatly value the learning and guidance provided by the professors. Thank you